In this question, we will use substitution to compute integrals. It is from the lesson 5.6. There are various different types of questions involved. Some can be used by u substitution. Sometimes we have to split the denominators, and sometimes the u substitution and rearranging the u, various types. We'll try to solve all of these problems. Now look at this. Here you can see x power 3 square root x power 4 plus 3. There is no way we have any rules we can apply and solve these terms. So what we do is we try to assume a certain complicated term as u. Now just imagine, for example, in this case itself, if I consider x to the power 4, okay, as u substitution, we consider it as u. Let us derive this. When I derive this, it will be du divided by dx, because with respect to x, I'm going to differentiate it. This is going to be 4x power 3. This is differentiation, not integration. Integral is what we are solving. Integration is what we are doing. But in order to do that, this u substitution involves differentiation at the beginning. Why do we do this is, now imagine we assumed u to be x power 4. We can apply this as u, but what about this dx? And what about this x cube? No, we cannot solve that. So here we are getting 4x power 3. So now this can be, okay, this is a constant, that's fine. But x power 3, we can do some rearrangement and solve it up. But here there are a few rules to remember. If you just do x power 4, then what happens is it will be u power 4 and then we have plus 3. It's going to be complicated because there is a square root. So what we do is, whatever is inside the square root, this is complicated, isn't it? We just take it as u. And then x power 4 plus 3. That is all inside the square root. Why? Because if we have just square root x, we know we can easily solve this. This is equal to x power half. And then when we integrate this, what's going to happen when we integrate it? Just add the power. By power rule, it's going to be x 3 by 2 and divided by 3 by 2 plus c. So we know how to solve this. But we don't know this one, right? So that is why our goal is to get this in terms of u. And now let's do du by dx. When we derive it, what do we get is 4x power 3, and this is gone because it's 0 when we derive it. Now we can rearrange this dx and get over here, we can apply whatever is remaining. So what we do is take dx to the other side and this down. So du divided by 4x power 3 is equal to dx, right? Now what we can do is, for the given equation, we will substitute whatever we have assumed. We have assumed u to be whatever is inside the square root, so that becomes u. X cubed, there's nothing, so let us leave it like that. What is dx? Dx is du divided by 4x power 3. Now simplify. This is gone, x cube gone. And integral square root u, this 1/4 divided by 4 means it's 1/4. I'll take it outside. And what is remaining is du. And now I can apply the rule. What is the rule? 1/4 of integral of u power half du. What is u power half when you integrate it? It's going to be u, add 1 to it. I'm directly going to write it. It's 3 by 2 by 3 by 2 du. Now this needs to be rearranged. You can use your calculator. 1 by 4 multiplied by 1 divided by 3 by 2. It's just complicated, but I'll write it out simply. What's going to happen is this is going to invert itself. 1/4 as it is, this will be 2/3 because it's divided by, when you take it up over here, this denominator remains in the denominator, but this the above term will be in the denominator, the down term will be in the numerator. That is into u3 by 2. I forgot to write plus c. It's not du, it's done. This du is gone. It'll be plus c over here. My bad. So here it's plus c. So the plus c will remain. This cancels. It's 1 time and 2 times. So you will have 1 by 6. The answer will be 1 by 6. Now don't write u to the power 3 by 2. What is u assumed to be? So we'll get that back. X power 4 plus 3. 3 by 2 plus c. This will be the final answer. So in order to solve this, you did all the substitution, rearrangement, and then you got it. Now let me just talk you through about this. Why did we do certain things? Why can't we keep this dx as it is? Because over here we have u, so then we have to integrate it with respect to u itself. So du must be there. You can't have dx. If it is x, then it's dx. If it was t over here, then it will be dt. But here we have u, so it must be u. And we cannot have two separate terms. X and u, this is not possible to be integrated. So now if you did some u substitution and then your x remaining here, then it's not possible to solve it. So whenever we use these methods, all these problems, when you solve it, what happens is the x terms get cancelled. You will get only u term. And numbers, the coefficient is fine. So this is how we solved it. Remember, when we are doing this u substitution, getting the u is very important. There are certain thumb rules. Whichever is a complicated term, which will make it easier, must be assumed to be u. Now, whatever is inside square root, we generally take it as u. If you have e to the power, then we take this entire thing as u. So it's not only inside the square root, it depends. If we have exponential, we will just take this as u. You will understand as we solve more problems. We take u such that we can simplify the other terms as well. Over here there is no other term, so it's fine. But we have to take whatever is inside the square root as u. When you are solving, that's a writing exam question, isn't it? So we have to write in details. Step 1, let me do the detailed steps here. Assuming u, or u substitution, you can just write anything. U is equal to 1 plus 10x, du by dx is equal to, this is gone 0, it will be 10 only, and dx, you can take that to the other side and you will have du by 10. So this is dx value. Step 2, I'm just going to write it over here at the left. Step 2 would be substituting in the equation, substituting in the given function and given question or function. So this is the given function. Now what happens is integral square root 1 plus 10x dx, right? Here we will have integral square root u du, not dx, because dx is du by 10. So we write du divided by 10. Now this 1/10 is a constant. We just have to integrate u du. What is the integration of square root u? You do not need to write u to the power 1/2. I'll just write it over here, but you can avoid this step. U power half. Instead of this, directly you can integrate as well. If you remember, this is half. Add 1, it will be 3 by 2. So 1 by 10. I can even do directly. Instead of 3 by 2, I know it's divided by 3 by 2, it will be multiplied by 2 by 3. I'm going to write it directly. U to the power 3 by 2. Whatever is there in fraction, that will be flipped and written over here when you're multiplying. Or you should just write it divided by, because if it is u power 2, what we do, u power 3 by 3, right? Or you can write it as u power 3 and this multiplied by 1/3. That's also fine. You know, it's just the same thing. Just ignore this. Now here we have done the integration. Don't forget to write plus c. Over here, can you simplify? Yes, you can simplify this 1 times 5 times. So the final answer would be 1 by 15. 5 times 3 is 15. U to the power 3 by 2 plus c. So that must be the solution for the second problem. But oh, no, it's not done yet. My bad. What is u exactly? We had taken that to be 1 plus 10 times x. So 1 by 15 into 1 plus 10x to the power 3 by 2, that is 1.5 plus c. This is the final answer. Make sure you write all these steps, step 1 and step 2. This, you can write the final step as step 3, you know. Substitute back, substitute, this is back u value. So that'll be step 1, assuming u and deriving du by dx and getting dx and u. Substitute them in the given question and derive it and leave it as u only. And the step 3 would be substituting back the u value. When you substitute back the u value in whatever is given, that will be the answer. I will solve other problems now, but make sure that you write in your exam in terms of steps. This is step 3. I'm just going to solve it directly. I'm just going to write it as it is and, as simple as possible and get the answer. You can even do that because this is very lengthy anyways. So just getting the answer is very important. Yeah, the first one was this, and then we substitute back whatever is u. Over here we got the same answer. Plus c is very important. What happens here? Now, if it was without the square root, just remember whatever is in the denominator, take it as u. If it was fractions here, it was no square root, then whatever is in the denominator, you take it as u. But here we have a square root, so just assume u is equal to cosine x. Du by dx will be equal to sine x. It's positive sine x. Oh, sorry, it is minus sine x, my bad. It's derivative, it's not integration. So remember about these. See, I get confused when I'm doing integration. I know integration of cosine is positive sine, but derivation of cosine is minus sine. And now then we have to write it as dx, so dx would be equal to du divided by sine x. Don't forget the sine, it's negative. See, now this cancels off. Now when I substitute this back, this will be equal to, I'm not gonna write this again. Here sine x will be as it is, divided by square root u, whatever is there inside. Dx is minus, I'll write minus outside, du by sine x. So this cancels off, you're remaining with the integral is there. Integral, I'll write minus sign outside, the negative integral of 1 by square root u. You can write above only du, that's also fine, or you can just write du over here. Now how would we solve this? Here it'll be, when you bring this up, it is negative power. This power is half. When you bring it up, it will be minus half. Power is minus half du. Now let me use the power rule. So it'll be minus u power minus half plus 1 divided by whatever is the answer. What is the answer here? Half plus 1 is positive half itself. Plus c. Now let me rearrange this. 2 comes up. So it'll be minus 2. Why? Because it's half, isn't it? It'll swap. 2 divided by 1. I'm not going to write 1 because divided by 1 will be the same number. And u to the power positive half or square root plus c. Now we'll substitute back whatever we assumed the value for u. U was assumed to be cosine x. Cosine x to the power half plus c. This is the answer. Or you might also write it by going a step further. It is square root of cosine x plus c. It's up to you. Let's just look at the answer. What is written? See, they have written this square root x plus c. But since it's writing exam, even if you write it half, you should get the full marks. But generally the square root radical symbol is written back. Let's do the next problem here. Now, do we assume cosine as u? You can, but then there's an issue. Why? Because over here, the more complicated term is sine cubed. So here, what I can do is, if I assume sine as u, then I can write it as u cubed, right? So u cubed can be easily integrated. Let me show you how it's done. Assume u to be sine x, and then du by dx would be cosine x. It's positive cosine x. And now dx would be equal to, dx only will be equal to du divided by cosine x. Now let's substitute back over here everything. Integral. Instead of sine, I'll write u to the power 3 because it's sine power 3, right? It's basically a whole power 3 itself. So sine x, the whole power 3 is equal to sine to the power 3x. It's the same thing. So I've assumed sine to be u, so it'll be u power 3. That is equal to same u power 3 itself. Now here then, what is remaining? Cosine x. What is dx? Dx is written, it can be written as du by cosine x. So cosine x cancels off. You have to just integrate u to the power 3 du, which is so simple, isn't it? It'll be u power 4 by 4 plus c. And now substitute what was u? We assumed u as sine x. It's 1/4 sine x plus c. That is the answer. I just realized I didn't put the power 4. So it's 1/4. This is 1/4. U power 4. It should be sine power 4 x plus c. This is a very important thing. Don't forget the power. Here you can see it is power 4, sine power 4 x by 4. Now this 4 can be taken out and written as 1/4, which I did. That's absolutely fine. And this is the correct answer. Solving these problems here. Now look at these two. Don't think u is equal to cosine t or cosine to the power 3, t to the power 3. No, this is wrong. You need to look at the other terms as well. It's just t squared. So you need to assume u to be t to the power 3. Now let's assume u is equal to t to the power 3. Now what happens? Du by dt, because it's not x, it's given in terms of t. That's absolutely fine. It'll be 3t squared. And then we can write dt is equal to du divided by 3t squared. So now it'll be, this will entirely change into t squared cosine u, because t to the power 3 is assumed to be u. Instead of dt, what do we have? Du by 3t squared. T squared cancels off, and you have 1/3 outside integral cosine u du. And what is the integration of cosine? It is sine, positive sine u plus c. And we have to substitute whatever is u back in over here. U is t to the power 3. That's plus c. So that is the answer. What about at the right side? Now here we need to look at this carefully. It is sine t multiplied with cosine t plus 3 whole power 3/4. If I take u as sine, it's gonna be just so much complicated. I will be able to cancel. I won't be able to cancel this because it's inside the power and radical. The power is 3, the radical is 4. So in such cases, whatever is there inside, I need to write it as square root c, because this can be written as radical 4 cosine t plus 3 the whole power 4. This is, sorry, not power 4, it's power 3 outside, isn't it? The above one is power. It's raised to the power 3 and radical of 4. So basically whatever is inside this, we assume to be u, but don't take this power as u. Just take whatever is inside here. So this will be u. U is equal to cosine t plus 3. Now let's derive this. Du by dt is equal to, cosine derivation is minus sine t. That's it. And now dt will be equal to, you have to swap the places, du divided by minus sine t. Now let's substitute whatever is there. Sine t will remain as it is. We have this to be u 3/4. What is dt? It is du divided by minus, I'll write it outside, and it is sine t. So this cancels off. You're remaining with integral of u to the power 3/4 du, which is very, very simple. What is the integration of this? It's minus remains. You add 1 to this. 3/4 plus 1, it's 1.75, or it'll be 7/4. It's going to be 7 by 4 plus c, but don't forget to divide it by 7 by 4 as well. So we can rearrange that and write it as minus 4 by 7. This flips, isn't it? What is u value? We assume u to be cosine t plus 3 the whole power 7 by 4 plus c. This is how we solve it up. And here we go, that's the answers. Now the first one was, yes, 1/3 sine t to the power 3. It's not sine cube t. The t was power 3 plus c. And this one was negative 4 by 6, 4 by 7, cosine t plus 3, 7 raised to the power 7 by 4 plus c. Now here they have not written all the steps. It's very important you follow these steps. So even if you write so much, you should get the full marks. Okay, this is the rearranging of u in terms of u and dt, and then we substitute back in the given question and we get this simplified version. We can cancel the signs and then we solve whatever in terms of u and then substitute back whatever is u. So you must be thorough in integration before we solve these problems. So if you are getting confused, that means you need to be thorough with the formulas, with assuming the values and everything. Then we can solve this up. So what happens over here? Now if I take the second term u, there's no way I can solve this. I need to take whatever is raised to the power. This entire thing becomes u here. So x squared plus 1, this is equal to, you can even write this term is equal to u, it's up to you. Now I've written this. Now here what happens is 2x plus 1 is gone, is equal to du by dx. Dx goes to the other side. Dx will be equal to du divided by 2x. Now what happens here? Integral of x remains. E is the same thing but raised to the power u multiplied by du divided by 2x. This x and x cancels. Now everything is in terms of u and numbers. So it's half integration of eu du. What is the integration of eu? It's the same thing, isn't it? Eu itself plus c. And here we can write eu was assumed to be x squared plus 1 plus c. So integration of this is just this. So that is the answer. So here we go. Again, the solution set, I realize now it's not so much detail. Okay, this is detailed. There are all the steps. They have written it in horizontally, 1, 2, 3, 4. But it's better you write it in detail like this. I'm also not writing in detail, but initially I've written the steps. This is step 1, step 2, step 3. I'll just mention the steps here. This first part, these 3 things are step 1. Until over here, you can write it as step 2. And finally, the answer, when you substitute the value back, will be step 3. And the given question must be written over here in the step 2, and then it's better to solve it. What about the 12th one here? What do you assume to be a u? Whatever is inside. U becomes e to the power x plus 4, and du by dx will be equal to just e to the power x. Because e to the power x remains e to the power x, and this is resolved to 0. Now we substitute it back over here, integration. Look, e to the power x, write it like that only. Sorry, I didn't rearrange this. Du by e to the power x is dx. So we need to even substitute dx value, isn't it? So square root u multiplied by du divided by e to the power x. See, now this cancels off. So what is remaining here? Square root u du. Please note my u becomes v at times, that is u. And the reason why we are using u is that's a famous method, u substitution. You can even assume it to be m. That's fine. M is equal to, and everything will be in terms of m, but it's generally used as u because it's called also u substitution method. And now what happens over here is integral u half du. It's u3 by 2. Now I'm going to write directly 2 by 3. That's fine, because if you've done so many problems, you must be very thorough with this. You don't divide 3 by 2 and then swap it. I'm just going to write u3 by 2. If it's fractions, flip the fraction and write over here 2/3 multiplied with u3 by 2 plus c. Now the last step would be substituting back the u value. The u value was e power x plus 4 raised to the power 3 by 2 plus c. So this is back here. So that would be the answer. Okay, I did some mistake. Let me just check what is the mistake here. Okay, everything is right. Yeah, this is correct. I'm sorry, I think so. The answer set over here is wrong. See, they have written over here correctly 2 by 3. This is all right. But substituting back u, I don't know why they wrote 1/2. It is wrong over here. It should have been 2/3. Okay, this is a mistake. Apologies for that. When I did the solution set, I went through a few of them, but I just didn't get time to go through all of them. So there might be mistakes. I've seen other mistakes as well. Please make sure you solve it by yourself and then compare. See, the question to our answer is 2/3 e to the power x plus 4, the whole 3 by 2. Let's solve these up over here. Now, how would you solve this exactly? Here, don't assume whatever is inside the square, just assume the entire thing as root x. Let's see now, to be very, very honest, I'm also just assuming as I look at these problems. I have not solved these by myself. I've gone through a few of them, but I've not solved all. So I just assume what is the most likely assumption that can be done to solve it. That's how we is because I can see that if I take this as u as square root x. Now when we derive this du by dx, this is x to the power x raised to the power half. So what's going to happen? Whatever is there, it comes down 1 by 2 and it's raised as minus half, because when you subtract 1 it will be negative half, and then you can rearrange this and write it as 1 by 2. This goes down, it's square root x because power half is square root x. I know this formula as an identity. When you derive square root x, it's 1 minus, I forgot to, no, it's positive, not minus, sorry. It's positive 1 by 2 root x. So I know when we derive, we get this. So I know something can be done here. Square root can be cancelled. So that's why I assume this entire thing as u. And so what is dx value? Dx would be du times 2 root x. Now let's substitute back over here. E to the power u square root x. What is dx? It's du times 2 square root x. And look here, the square root cancels. You have 2 outside, the constant can be removed outside. E to the power u du. You know the integration of eu is the same thing, so it's du eu plus c. That's the answer. I remember, one of the students before asking me this, when we integrate this, why don't we do u plus 1? See, sometimes some students, right, when they come to this step, eu du, they might have this doubt, because I remember a student asking me long back, and even I was a bit confused and then I realized, okay, when you integrate eu, it's the same thing. It's not the power rule or anything. You don't add 1 to it. It's not like u plus 1 or anything. No. Integration of e to the power u is just eu because it's exponential function. So the reason why I told is, if at all you're getting this doubt, make sure what is the function. Because it's exponential function, we take whatever is up above. If it was any other function, no, we had to take a different u value. Now this is the answer, but you have to substitute back whatever we assume to be u. It's root x plus c. So that will be the final answer. Hope that's clear. It is 2e root x plus c. The next one, whatever is inside this, let's assume as u, because there is no other way you could simplify this. And when we assume that as u, I know when we derive over here, power 2 will also come. So this can be cancelled out. So u will be 1 by x. So what's going to be du? 1 by x is minus 1 by x squared. But let me do it in steps. Du by dx would be, this is equal to x to the power minus 1. So here minus comes down. X power minus 2, which can be written as minus 1 by x squared. But I'm sure many of you might know this as identity. Derivation of 1 by x is minus 1 by x squared. You can directly write the answer there. Then we write du is equal to dx to the other side, and this minus divided by x squared. What I did is I took dx to the other side. Now this is the equation we have to look into. Dx, and this x squared to the other side is not down. My bad. It's multiplied. Look carefully. I'll just write in detail. 1 by x squared, right? Minus 1 by x squared. Let's move the x squared to the other side. It will be x squared times du, and the minus to the other side, that will be equal to dx to the other side. So this is the substitution for dx. Now let's substitute everything. Cosine u divided by x squared times minus, I'll write it outside, dx will be x squared times du. Now this cancels off. So you have just cos u du. And how do you integrate this? It will be cosine integration is sine x. It will be minus sine, not x, it is u plus c. Now substitute back whatever was u value. It was supposed to be 1 by x. That is the answer. It should be negative sine x, sine 1 by x plus c. I'm sure many of you might feel you're thorough with these problems, so you just can skip this video. Skip these questions and go ahead. I've got many students requesting me to solve all the problems from 5 to 40. So I will solve all the problems from 5 to 40. So it's going to be a long video. If you want, you can stick through it. But if you already have understood these problems, then just move ahead. Skip this parts, which just go to the ones you have difficulties with. Square root natural logarithm x. I know the derivative of natural logarithm x is 1 by x. So I have to assume this has u. So whatever is inside square root, we generally assume to be u. So natural logarithm x. Du by dx would be equal to 1 by x. So du by, sorry, it's not by now. It becomes multiplication. X times du will be equal to dx. So now it's substituted over here. It's going to be root u by x times dx is u times, sorry, x du times x. I'll write it as. It's x times, it's the same thing. I'll cancel this off. So you're remaining with square root u du. We have done the integration of square root before as well. It's going to be u, half plus 1 is 3 by 2, that's 1.5, and when we write it over here, it's 2 by 3 plus c. It's not over, we have to substitute back whatever we assume to be u. It's ln x to the power 3 by 2. Plus c is very important. Now this is writing part. There won't be any options, so if you're forgetting the c, you might lose marks. So don't forget this plus c, because there is always some constant of integration that can be there over here. It can be 0, 1 to any number, or negative or positive numbers. What about this one here? I know derivation of tan x is secant square, right? So I'll just take u is equal to tan x. So du by dx is equal to secant square x. And now I'll rearrange du by secant square x will be equal to dx. Let us write it in proper steps below each other in proper method. I'm just writing it to the question itself because I'm just solving it. I'm just showing you the steps over here. So it'll be secant square x square root u times du divided by secant square x. This cancels off over here. So again, you have integration of u power half or square root x. You can write anything du. It's the same thing. Can you see over here? But it's just that the final answer will vary. It's 2/3 of u to the power 3 by 2 plus c. Now what happens is it's 2 by 3. U value which we assumed was tan x here. Tan x 3 by 2 plus c. So that is the answers. You can see the coefficients plus c, everything is same, but the terms, natural logarithm, over here we have natural logarithm x, over here we have tangent x. So those are the answers. These are the final answers. You can see everything is same, only the values of. Okay, now I forgot one important thing. It is. No, this is correct what we have done. Okay, this is wrong. I thought I had assumed wrongly. See, we have assumed whatever is inside the square root, that is tan x, and then we substitute back inside the square root. The square root becomes half, and then we get this answer. Here, the final answer is wrong. Again, apologies for this. Here, there is no square root. The square root is the error. This should not be there. It is only tan x to the power 3 by 2 because we have already simplified using the square root. So this is correct. This is now correct. Which see over here, u is tan x. The square root was the mistake over there. Now, what about these problems here? In the first one, in fact, we have u itself, du. So what do we assume? You can take anything x or y or t. I think so. Generally, t is taken if there is already u. Yeah, t is taken here as well. But over here it's v, so you can take u. Let's solve these problems up. We have square root and square root plus 1. Of course, this is a bit more complicated than this one. And when we derive this, I know when we derive square root, we'll get back square root as well. It may be in the numerator, or if it'll be in the denominator, but still we can work with that. So what I do is assume u, not u, anything, any alphabet other than u. We generally take t is equal to square root u plus 1. Or you can take it as x, up to you. And then what we are doing is deriving this dt with respect to du. because u is the term inside, that will be equal to, or if you're getting too much confusion, right? Because I remember when I was in my school, whenever I get any other term, I used to rewrite this question as x. I mean, it's a very silly thing to do, but in terms of dx, and then just solve it up. Because over here, especially u substitution, I like it as u and x. For some reason, it'll be du by dx. You can do the same thing, this everything over here instead of u, you can assume to be x and then solve it up. That'll be also fine. It'll be absolutely correct, no problem at all. But the finally substitution, substituted back into whatever variable was there. Now let me do a dt by du. Over here integration will be 1 by 2 root x. I'm not going to solve in detail, not going to take 1/2 and everything. I know the identity of square root x is 1 by 2 root x. But here, since we have u, it's going to be square root u. Plus 1 will be 0. What do we need here? We need du. Take it to the other side. So it will be dt is equal to du, and this is multiplied here to square root u. Now let's substitute back in the question. It's going to be 1 divided by, what is square root, no, leave this, square root u. What is square root u plus 1? Whatever is inside the bracket is considered to be t. And du is 2 square root u dt. Now the square root u cancel off. You have not 1, it's 2 divided by t dt. What is 1 by x integration? Now natural logarithm derived as 1 by x. Over here, just remember, write the t outside, it will be natural logarithm t, the magnitude of it, plus c. So that must be the answer, but substitute back whatever we assume t to be. It is square root u plus 1 plus c. So that must be the answer. So these are the exact steps to solve. That is the answer. Now here you don't need to write magnitude. You just have to know that you can't have negative numbers here. So that will be the answer. It's not required to write magnitude. You can just write brackets. It's fine. What about the next one here? Whatever is down, when I derive power 2, it's going to give me power 1. So this will be cancelled off. So let me assume whatever is over here, u is v squared plus 4. Let me take it as du by dv here. That'll be 2v. That's it. And now let me write it in terms of v. So it'll be du divided by 2v. That is equal to dv. Now I'll substitute everything in the given question. V remains, but the down term becomes u, and dv will become du by 2 times v. This v and v cancels off, so you have this 1 by 2, which is in the denominator. I'll take it out, half integral 1 by u du, and that is half of natural logarithm u. This is a habit which I do, but anyways, you can just remember u must be positive. So let's substitute back. What is u? U value was v squared plus 4. Now here you don't need the magnitude. Doesn't matter what value you take, it will be positive. So there's no problem at all. So that is the answer here. Half natural logarithm of v squared plus 4 plus c. Then what else we got? We have over here, again it's similar problem. Okay, now when we solve this up, we will get 1 by x, see, natural logarithm. So don't take this power 2 as u, just whatever is inside. Natural logarithm x plus 1 is equal to u. And now let's solve it up. It's going to be 1 by x equals du by dx. We need dx value. So dx will be equal to du times x, or x times du. This is at the right side, it's u. Or x times du, it's the same thing. I'll substitute back in the given question 4 divided by x. Whatever is there over here, it becomes squared. And this becomes x times du. So this x cancelled off. You have 4 integral 1 by u squared du. What is 1 by u squared? We can take this up. It'll be 4 integral u to the power minus 2 du. That is 4 of, not integration now, let's use the rule. It'll be u minus 1 by minus 1 du. It's just that the sign changes here. Minus 4 u minus 1, not du over here, my bad. It is plus c. Once we apply the integral rules, it's plus c. So that's the answer. Now all I need to do is substitute back whatever is u. Minus 4 times ln x plus 1 plus c. This is power minus 1. I can take it to the denominator, so it will be minus 4 natural logarithm x plus 1 plus c. That must be the final answer. Here we go. It is. Now they have not done this last step because it's minus 1. I took it down, but you can just leave it like that as well. But I would suggest you go ahead with this step as well. It's writing exam. You can get it as simplified as possible. The next problem here, we have tan 2x. Now there is no way you can use tan x. There's no rule to integrate tan x. But we can integrate sine divided by cosine, because tan theta is equal to sine theta divided by cosine theta, right? I'm just going to substitute that. Instead of tan, now we don't have theta, it is 2, 2, 2 and x instead of theta. This will be equal to integral of sine 2x by cosine 2x dx. Just remember that. So now what is u? U will be whatever is in the denominator, cosine 2x. I hope you remember I told in one of the previous problems, here what is down, the denominator is considered to be u. Now let's derive this. Du by dx would be equal to minus sine 2x. Now it's not over, there's a chain rule. Once this is done, whatever is inside is also derived, it's 2. This is the chain rule. Cosine 2x derivative is minus sine 2x. But then we derive whatever is the x value, because it's not just x, there is something else as well. 2x derivation is 2 because 1 is dissolved to 1. X will become 1, so 2 remains. Now then what is dx? Dx will be equal, going up, this goes all down. It'll be minus 2 times sine 2x. So now let's rearrange this question. Sine 2x remains, divided by cos 2x is u. And what is dx? Dx is du divided by minus, I'm going to write it outside. Because why, the reason why I always write minus outside is, sometimes if I put it inside here, I forget it in the next step. So whenever I put this out, it's there over there, isn't it? Now it's up to you. You can write it over here, take it out later, but it's just a habit which I follow so that I don't forget the negative sign. Because it's easy to forget the sign when you go to the next step, when you cancel it. See, now this is cancelled. I tend to forget the sign. So that's the reason I always put it outside. So it'll be minus 1 by 2 integral 1 by u du. We know the integration of 1 by u, that is natural logarithm u. So negative half ln u plus c is the answer. But you need to substitute back what is u. U was considered to be cosine, it's cosine 2x, not sine, cosine 2x plus c. So there we go, that is the answer. It is minus half natural logarithm cosine 2x plus c. Now here it is very important to put this. Now why? Because there is a possibility that there can be a negative answer here. There is positive and negative answer in a cosine function, isn't it? It starts from up. So that's why we put the modulus symbol. Now, why didn't we put in the previous problems? We had the similar one, natural logarithm. Let's go back 1 second. Here, because it's squared, doesn't matter what value of v, we will have a positive answer. And then we are adding 4, it'll never be a negative number. That's why there's no need of the modulus symbol. Here as well, square root u, square root of any, only positive numbers is possible. You can't have a negative number when you have square root because it's undefined, right? It'll be imagined number. So whatever is u is only positive. Already we know that. And you're adding 1, no matter what, it'll be negative. So we just put the brackets. But here, there is a possibility that cosine 2x can be negative. So to avoid that, we write the modulus symbol. So if you're wondering why did we write it over here and why didn't we write it over here, that is the difference. Because over here, cosine 2x, there is a possibility of it being negative. So it'll be minus, modulus will make it positive, and that's the answer. Now, what about these problems? It looks a little big. They're all same way to solve. Okay, now here, this one, don't think whatever is inside square root or the denominator. No, When I look at the top term, I know it's sine inverse x. You need to know the rules of the derivatives here. If I assume u to be sine inverse x, what is du by dx? That is 1 by square root 1 minus x squared. To be very honest, I didn't have this identity in my mind, but I knew over here when I looked at it, okay, this is the identity, I remember it. So that is how we do it. Now, let's rearrange this. Let me take dx to the other side and this to the other side. So it will be square root 1 minus x squared du is equal to dx. So we can rearrange everything here because this will cancel off. U to the power 3 divided by square root 1 minus x squared, and this dx will become square root 1 minus x squared du, and this cancels off, so you have basically integration of u cubed du. What happens here? It will be u power 4 by 4 plus c. Here we are to substitute back whatever is u. We can write 1/4 u is sine inverse x plus c. This is it. So this is the final answer. And we can see here it's 1/4. Now they have written divide by 4. It's the same thing, sine inverse. Okay, I've forgotten one important thing. Power 4. See, I've done this even before in one of the problem. So I just checked the answer because, whether I'm right. I do silly mistakes. See, everything is right. The power 4 was missing. U is raised to the power 4, isn't it? U is sine inverse x. Correct. The whole raised to power 4. This is the correct answer. So that's what was missing. That's how we solve it up. Now, what about this one here? Look, secant square integration. I know it is tan x. So I'm not worried about this. I'm just worried about these two. So if I just assume x cube as u, that's more than enough. Because when you derive it, it'll be power 2. And I can cancel this off. Because integration of secant square is known. It is tan x. So what I'm going to do is u is equal to x cubed. Du by dx is equal to 3x squared. And now here it will be du by 3x squared, that is equal to dx. Now let's substitute everything back in the given question. X squared secant square u, not x, times dx will become du by 3x squared. This x squared cancel. Now everything is in terms of u and a number. The number outside, 1/3 is taken outside. It will be secant square u du. The answer will be 1/3 tan x, because integration of tan secant square x dx would be tan x. But here it is u, so I'll write tan u plus c. What was u assumed to be? It was assumed to be as x cubed. So I'll put it back over here, x cubed plus c. And here we go. That is the answer. So 1/3 tan x cubed plus c. Looking at the answer over here, okay, they have not at all taken. Okay, oh, I'm so sorry. This is not the question. It's a different question altogether. This is wrong. Apologies for that. This is the correct answer. I have not done any error over here. It'll be tan x, and yes, it'll be. You have to substitute whatever was u back over here and be x cubed. So please consider this the correct answer and ignore what was there in the solution set. I'll just leave it over here for a second. You can write it down, pause the video, take a screenshot or something. Moving on to the next one, 23rd, there's A and B. Okay, these ones, right? You can look, they are much similar, but this u consideration will be different over here and over here. Let me tell you why. Now looking at this one is a bit, this is easier. If you know square root 1 minus x squared, it's sine inverse, isn't it? So what is the sine inverse formula? If you derive sine inverse x, it's going to be 1 by square root 1 minus x squared. So we need x squared here. If you have x squared, then we integrate this, it's going to be sine inverse x in the final answer. But if we take x squared, there is x4 here, x to the power 4. Okay, now if we assume u is equal to x squared, what can I do? That's fine. Let me derive it. Du by dx. I'm going to get 2x. This is also very helpful because I can remove this x off now. Because over here uh, du by 2x will be equal to dx, right? So when I substitute over here, denominator x, numerator cancels off. So everything is helpful. But what about this? I have x power 4. So all you do is square this. You have assumed u is equal to x square, right? Square this on both the sides. So it will be u power 2 is equal to x power 4. So instead of x power 4, I can write u raised to power 2. And then here, instead of x, we have u, and absolutely integration of this will be sine inverse u. We can do that. So what we do over here is, after this much, after you understood this, here I'm going to rewrite this as x divided by square root 1 minus u squared, because x power 4 is u raised to power 2. And this dx becomes du divided by 2 times x. And this cancels off now. Now what is remaining? I'll just raise this a little bit over here. So here now you're remaining with integral this 1 by 2. I'm going to remove it outside. I'll write 1 divided by square root 1 minus u squared du, which is equal to, I'll just write it over here, half of sine inverse of u plus c. Now what was u substituted as? U is equal to x squared. So sine inverse of x squared plus c is the correct answer. So this is it. That will be the final answer. It's half sine inverse x squared plus c. It's not x. We did that, in the manipulative method. We took u as x squared, and then we used u squared in the question because u squared is x power 4, and then we could easily use the sine inverse formula. But we cannot use whatever we did over here to the next problem. If we take u as x power 2, the derivation will be 2x. Here we will have du by 2x, which doesn't help us. If we cancel it, still x power 2 remains. So what we need to do over here is take x power 4 u as this itself. But you can't just take u as x power 4, because then it's a problem. We cannot solve it when we go in the final stages. You have to assume whatever is inside the square root as u, and this will become 0, and then we can cancel this off. Let me show you. Whenever the difference is just 1, just take whatever is inside the square root. The power should be higher than the above. That is assumed as u is equal to 1 minus x power 4. So what happens when you assume derive it du by dx? It's going to be minus 4x power 3. And let's rewrite this. Du divided by minus 4x power 3 is equal to dx. So now we'll substitute all these things in the given question. It's going to be x cubed as it is. Whatever is inside the square root is u. And what is dx? It's du. There's minus sign, which I'm going to write it outside the integral, divided by 4x cubed. Then cancel this off. So you're remaining with minus 1/4. I'm going to write this out. It's integral 1 by square root u is 1 power half. It's u power half du. So what happens is here, it'll be integration of negative half, u raised to negative half, because I'm just going to get it to the numerator, the power becomes negative. And then you have du. Let's solve it up. It's minus 1/4. And what is this? It'll be u power half, isn't it? Why? Because minus half plus 1 is half, divided by half, which will be multiplied by 2 by 1. You don't need to write 2 by 1. You can just write 2. That's enough. Plus c. It's not du anymore. It'll become plus c. That is integration constant. Now here you can write 1 time, 2 times, and you're remaining with minus 1 by 2. What is u value? U value was 1 minus x power 4 the whole half. Sorry, it's 1 by 2 plus c. You can also rewrite this as minus half. It will become square root 1 minus x power 4 plus c. It's as it is we had got initially. It was written in square root radical. Let us look into the answer. Here we have negative half. They have not written in radical, they have just written the power. It's the same thing. Over here, this is absolutely fine. Let me clear this. We can even go ahead and write in the next step square root 1 minus x power 4 plus c. This is the correct answer. These two problems are also similar to just the one which we solved a while ago. In the first case, we do not need to assume u as the entire denominator. I'm just going to assume u one more than this because there's a big difference. I'll write u is equal to x power 3. I'll tell you why. Because du is equal to, du by dx is equal to 3x squared. And what is du by 3x squared? That is equal to dx. Now when I rearrange this, x squared, now I'll write this in a minute, but du by 3x squared, this x squared cancel. So it really helps me a lot with that. But I do not have x power 6. I have just x power 3. How about we square this? U is x power 3. Let me square both the sides. And what's going to happen? It's going to be u power 2 that is equal to x power 6 because we multiply the powers here, isn't it? 2 times 3 is 6. So here I'm not going to write u, it's u power 2. And now this integral, it's 1/3. I'm going to write it out 1 by 1 plus u squared du. It's similar to 1 by 1 plus x squared dx. It's tan inverse x. So the answer is 1/3 of tan inverse u in this case plus c. That is equal to 1/3 tan inverse. What was u initially assumed to be? It is x cubed plus c. So that is the final answer here. That's it. So it's 1/3 tan inverse x cubed plus c. What about this one here? Here what we do is we will have to assume u as the entire denominator because then only the numerator can be cancelled. It's 1 plus, don't just do this one term, the entire thing in the denominator. And du divided by dx would be equal to 6x power 5. And let's rearrange this. It'll be du divided by 6x raised to the power 5 is equal to dx. And let's substitute back in this given questions. So we have x power 5 as it is divided by 1 plus x squared is u, and dx is du divided by 6x to the power x raised to the power 5, which cancels that out. You're remaining with 1/6 of 1 by u du. This is natural logarithm now. Don't write, it's not radical or anything. Don't write, there's no square root. So don't write this as u raised to power -1, then we cannot solve it because it'll be divided by 0, it's undefined. We have to use natural logarithm, 1 by 6 ln u plus c because we have used the integration. It's 1 by 6 ln, what is u initially assumed to be? 1 plus x raised to power 6 plus c, that'll be the answer. And that's it. So here again I forgot one important thing. We do not know the x value. No, it doesn't matter here. You can write the brackets. Why? Because whether it's a negative or positive number, it's going to be positive itself, and you add with the positive, adding with 1, it'll be always positive. So this is fine. This is the correct answer here. So this one, 1/6 of natural logarithm 1 plus x raised to the power 6 plus c, that's the correct answer. Okay, these are not like the previous ones because I can see it's 1 plus x divided by 1 plus x squared. There is no way if I take the denominator, I can cancel the numerator because there is plus over here. If it was single term, then it's a different thing. Whenever you see such problems where you have 1 plus x in the numerator, even in the denominator it's 1 plus x, what you need to do is split this out, like make them fractions. Integral here, imagine I have x plus y divided by 2. Can I write this as x by 2 plus y by 2? Yes, the denominator is same. I can write it together, x plus y, isn't it? The same way, I'm going to split this denominator to 1. It's 1 plus x power 2 plus x by 1 plus x squared. So the denominator is same. And I've just split this. I can rewrite this as the above question. That's absolutely fine. Dx is also split over here, both the problem. This is integrated. Now what is the integration of 1 by 1 plus x squared? Now I can do u substitution over here. No, do you need a u substitution here? 1 by 1 plus x squared is tan inverse. I can directly tell it's tan inverse x. You can't use u substitution because then it will be error because there's no x to cancel up with. But here I can't do that because there is x in the numerator. So what I do is, this is done. For this part, I need to do u substitution, which I'll do it over here. U is equal to 1 plus x squared. Du will be equal to 2x. Du by dx. Okay. So what is du by 2x? That is equal to dx. Now I will substitute over here. Let me solve that question up over here and then write the answer, because I've written the answer over here already. It's plus c1 because there are two c's, or I can write the answer and directly write 1c because c1 plus c2 will be just c. 1 plus x squared. You can write this and then solve first part and second part individually. So step 1, solving this one answer. Then step 2, and then finally write the sum of those both. Here we have x by 1 plus x squared, and we have assumed many things. X divided dx is there. That's a very important thing. Down denominator is u, and dx will be du by 2x. Cancel the x's. So over here, what is remaining exactly? Your remaining, the integral and all is there here as well. So it'll just be 1 by 2 integral. This 1 by 2 is there. 1 by u du. Let's solve this up. Half of natural logarithm u plus c. That's the answer. But you need to substitute back what was u initially assumed as. It was 1 plus x squared plus c. So let's substitute back the answer here. Because we have already 1c, c1. We'll consider that to be c2. It's half natural logarithm of 1 plus x squared plus c2. Or we can write this together as tan inverse x plus half natural logarithm of 1 plus x squared plus c. That's it, because both are just constants, right? You can add those two numbers and that'll be just another number. That should be the final answer. It's tan inverse x plus half natural logarithm 1 plus x squared plus c. Now here you do not need to put this modulus. Why? Because anything, any squared, see the x squared will be positive number only, because when you square it up, it'll be a positive number no matter what, and you're adding 1, so you don't need to put the modulus. Absolute value is not required. What about the next problem here? Okay, this is a bit easier because I can see the denominator is as a squared minus b squared. That is equal to a plus b, a minus b identity. So it's a squared, differences of squares. So let me write this as 1 plus x divided by 1 plus x, 1 minus x dx. So it cancels off, right? What is remaining exactly? 1 by 1 minus x dx. This is what you need to solve for. Now how would you solve this? You can just assume whatever is down to be u. So u will be 1 minus x, because we do not know the rule for this. It's not 1 minus x squared or something. We don't have an actual rule. So we write u is equal to 1 by 1 minus x. Derive this, du by dx is equal to minus 1. So what is basically dx value? This minus 1 to the other side, minus du will be equal to dx. So now substitute back in this particular question. We have simplified the question already. Here it's going to be 1 by u minus, I'm going to write outside du. So minus, what is 1 by u? It is natural logarithm u plus c. Now what was assumed to be u? That was 1 minus x plus c. So that is the final answer. It's negative natural logarithm of 1 minus x plus c. Okay, here now, I forgot to write one important thing. This is correct, everything is correct. But modulus symbol, that's modulus means absolute value symbol, is very important. Why is that? Because I have minus x. So x can be phi. It'll be minus phi plus 1. That is equal to minus 4. Which will make it undefined. So I have to write this modulus. If it is positive over here. See, in this case, it's x squared. No matter what, you take a minus value, minus 5, squared will be, this whole squared will be 25. So it will be 25 plus 1. If x is minus 5 or plus 5, negative or positive, it's going to be positive only, the answer. Not in this case. So that's why we write the absolute value or the modulus. So it's minus, yeah, that's the correct answer. How about these problems? Now, these do not need to be split like what we did just now. Why? Because over here, it is just a single term, 3 root x. But this is now another way, a tricky way. If you try by any u substitution method, this cannot be solved. If you take an x cube as u, let's derive du will be 3x squared. Now it will be divided by 3x squared. Can you cancel this? No. What if I take square root as u? Square root as, okay, this will help us a little bit. Du by dx, that will be minus 1 by, sorry, it will be positive 1 by square root x, right? This is the identity for square root x derivative. But, you know, this is assumed to be u. This cannot be cancelled if you assume this to be u. Now, what do we do? What we can do is, if we take this entire thing as u, it's not gonna work out. We need to manipulate this x to the power 3. So how do we manipulate is, instead of u be taken as x power 3, let's take it as 3 by 2. Why? Because this is radical, that's power half. So x power 3, and this is x power half. That's basically, we have x power 3 in it and we have square root x in it. When we simplify this, we are going to get 3 by 2, isn't it? Now what happens if you derive this? Du by dx will be equal to, when we derive this, it's just going to be 3 by 2. We have to subtract this by 1. 3 by 2 is 1.5, isn't it? So we are remaining with x power half. What is this exactly? This is 3 by 2. Sorry, x it is, not u. The root radical of x or square root of x. That is du by dx. What do you want over here? You need dx. So let's take dx to the other side and all these terms to one other side. It'll be 2/3 du by radical x or square root x, that is equal to dx. Now we can simplify a lot. What happens here? It's going to be integral 3 radical x, square root x, sorry, 1 by x cubed will be 1. See here, we need what? X cubed, right? How can we get x cubed from u? We can't write u. U is 3 by 2. So what do we do this? Here we square it up. U square over here, let's square this, x power 3 by 2, the whole power squared. This power 2 cancels. You're remaining with u x cubed. I should have told that earlier, but anyways, this is how we get x power 3. So when we divide this by 2, we can just square both the sides and get it, right? So now this is u power 2 dx. Dx is, sorry, du. It's du and all these terms, du by square root x multiplied by 2 by 3. So what can be cancelled? 3 can be cancelled with this, square root can be cancelled, 2 can be written outside, integral 1 by 1 minus u squared du. See, now this is tan inverse. So I can easily write this as 2 tan inverse of u du. And what is u assumed to be? It can be written as u is equal to tan inverse of x to the power 3 by 2. It's not du, sorry, after you use the integral, it is plus c. Yeah, this is the answer. It should be 2 tan inverse of x 3 by 2 plus c. You can see here, that's the correct answer. That is how we solve it up. Let's go back over here. I'll just run through it again. We are not able to take u as x cube or x power half or square root x. It's not possible. So what we do is we need to assume u such that when we derive it, we have square root x. So all you do is whatever is the power, you divide it by 2. That means the square root is involved. So here, this is as saying as we have x cubed times the square root x. So here when we derive this, we will have 3 by 2 x power half, which is square root x. Now we can cancel this off and then rearrange the terms and get dx and substitute back over here. 3 root x divided by 1 plus. The problem is we have x 3 by 2 as u, not x power 3. If you square on both the sides, you get u square equals x power 3. And that can be used as u square, instead of x cubed, we can write as u squared. And dx becomes du by square root. All these terms needs to be written. Cancel out whatever can be cancelled, and you're remaining with 1 by 1 minus u squared, which is tan inverse. So that's it. Look at the next one. It's the same way. Only thing is over here, we have phi by 2 to do. So let me show you how it is done. We assume u to be x power phi divided by 2. Remember, u power 2 is equal to x power phi. So u squared. Now we derive both the sides du by dx. That is going to be phi by 2 times x power. Now what is x power phi by 2 plus minus 1? It's 3 by 2. Now if you look carefully up above, we don't have x raised to 3 by 2. But what exactly is x raised to 3 by 2? It is 1.5. X is 1.5, right? So this means there is one whole of x and one half of x. So that is x and square root x. Or over here, if you simplify this, it's much easier. In the numerator, this is equal to integral x power 1 and power half. That's going to be 3 by 2 or 1.5 divided by 1 plus x power 5 dx. So this is enough for me. It's better to simplify this rather than rearranging this. So now let me write what is dx. du will be equal to, take this 2 to the other side, phi down, x 3 by 2. That is equal to dx. Now let's substitute everything what we have assumed here. X 3 by 2 remains here for now. 1 plus, what is u squared? X to the power 5, that is u squared. We have du 2 times, I'll write, let me write it over here. 2 times du divided by 5 times, this all multiplied, x power 3 by 2. That cancels off. 2 by 5, I'm going to write it out. 2 by 5. What is remaining? Sorry, it's integral 1 by 1 plus u squared du. Now again we have tan inverse here. It's 2/5 of tan inverse of u plus c. But what is u exactly? 2 by 5th of tan inverse of x raised to the power 5 by 2 plus c. So this is the final answer here. We can see it's 2/5 of tan inverse x raised to 5 by 2 plus c. Okay, this is another type. It is not like the previous ones. It is a little different here. See, there is no way we can assume the denominator and solve the numerator because we have again plus. But we can't even split this. If you split 2t by t plus 7 and then 3 by t plus 7, it's not helping. We don't have an identity to solve. If it was x squared plus 1, like the previous problems, we were able to solve because there were identities. But this do not have any identities even if you split. So what can we do? We have to do another sort of manipulation here. Let's assume u as whatever is the denominator for now. U is equal to t plus 7, and let's derive this. Du by dx dt is equal to 1. This is 0. And what is basically dt? That is du is equal to dt when we take it to the other side. Okay, this is helpful, but whatever is down is u, dt is du. But what do we do in the numerator? There's nothing we can do, is it? Look at this given term, assumed term, u is t plus 7. What if I tell what is t? What is t in this? Let me take 7 to the other side. U minus 7 is equal to t, isn't it? Now, can I substitute that over here? U instead of t, I'll take it as u minus 7 plus 3. Now, everything is in terms of u. Can I solve this? Yes, absolutely. Let me Simplify this, it'll be 2 multiplied by with u and minus 7. So it'll be 2u minus 14 plus 3 divided by u, that is du. And here we have 2u minus 11 divided by u, that is integration of du. And what else? Let's split them up. 2u by u minus 11 by u, integral du over here and over here, integral as well. This is minus. So first one will be just 2, integration of 2 du. The second one will be minus integral 11 by u du. Don't we know how to integrate these both? Absolutely, we can easily integrate them, right? I'm just going to write it up over here. The first one will be integration of 2 into u. That's it. I'm not going to write plus c1 plus c2. I'm just going to write 1c together. Next one will be minus 11. 1 by u will be ln modulus u plus c for both of them. And here, what was u assumed to be? U is t plus 7. So it's 2 times t plus 7 minus 11 ln. Here, write modulus t plus 7. Absolute value of modulus plus c. This is c over here added. Now we can simplify it further. Like you can multiply this if you want. You can leave it like this. Let's just look into the answer, how they have written. They've just left it as it is. So it is 2 times t plus 7, that is 2u, minus 11, natural logarithm, absolute value of t plus 7. Why? Because if t is, say, minus 10, minus 10 plus 7 is minus 3, which can be a negative value. So we write modulus of this absolute value, plus c. This problem as well is similar to the previous one, because inside the radical over here, it is not more than 2. If it was 3, then it was easier. But here we have power 2 in the numerator and there's only t. We can't solve this in any easy way. So what we do is, whatever is inside the radical, take it as u. U is t plus 3. Let us derive both the sides. It will be du is equal to, du by dt is equal to 1. And let's take this dt to the other side. It will be du is equal to dt. So what is now t or t square? From this, how can we rearrange and write t? So u minus 3 will be equal to t. But the problem is we have squared, so we have to square both the sides. And now apply the square. This is a minus b the whole square identity. It will be a squared minus 2 times ab plus b squared. Minus 2 times ab plus b power 2. Same way we write u power 2 minus 2 times 1. Sorry, 2 times u. A is u and b is 3. Don't write the negative symbol because it's already taken care for. So it's 2 times u times 3 plus 3 squared. That is equal to t squared, isn't it? So it's u squared minus 6u plus 9. That is equal to p power 2. Now we will substitute all that we know and simplify. It's integration of u squared minus 6u plus 9 divided by, what is this entire thing is u, radical root 3, right? I'll write it as 1/3 because that is equal to radical 3. Because it's 1 whole power 1 divided by whatever is in the radical. That is in terms of du, because dt is equal to du. Now we can divide these terms. First term would be u squared divided by, see, I'm not going to write, you can write it like this, u squared divided by u power 1/3 minus 6u divided by u power 1/3. Then plus 9 divided by u power 1/3. This is one step, but I'm going to directly write what will happen here. I'm just going to write an easier way. This is one way possible. Okay, you can write it like that, no problem. Another way is, since u and u is there, all you write is u power 2 minus 1/3. Then du, oh, we can write that later, sorry. Let me just write it once because there are 3 terms, minus 6u, what is the power here? If it's nothing, it's 1 minus 1/3 plus 9u raised to minus 1/3 because this is just brought up. We have split this to all the 3 terms And then we can write this. You can skip this step. If you want, you can write it. It's up to you. Entire thing times du. We have to put bracket because it's more than 1. Okay, it should be properly written. And now what else? We will simplify this. U2 minus 1 third. You can use your calculator. Over here we can write it as 6 by thirds. So multiply 3 and 3, it will be 6 thirds. It will be 5 by thirds. Minus 6 minus, sorry, it's not minus 2 by thirds, it's positive 2 by thirds. 2 thirds are remaining. Plus 9u negative 1 thirds du. We can apply the power rule. Now you don't need to write this individually for each term, it's understood. I'll just apply the power rule over here. It'll be u 5 thirds plus 1, that's going to be 8 by thirds. And I'm not going to write divided by 8 by thirds, I'm just directly writing 3 by 8 here. Minus. What's going to happen here? I forgot to write the u itself because it's not 6 raised to 2 thirds. It's 6 times u raised to 2 thirds. Now the 6 remains multiplied by, when you add 3 to 1 to 2 thirds, it's going to be 5 thirds. U raised to 5 by 3. And here what's going to happen is it'll be 3 by 5. Plus 9. What happens here? You add 1, it's going to be 2 thirds. And here it'll be 3 by 2. Plus C. This is it, but you can simplify this. You can simplify and write it as 18 here, and that's it. But then you have to substitute what was u. So u is 3 by 8 times t plus 3, over here it will be 8 raised to 8 by 3, minus 18 by 5 times t plus 3 raised to 5 by 3, plus 9 times 3 would be 27, and half of that would be my mind is, just tired. It's 13.5 for now. That's a 13.5. Or instead of, I don't know why I did that, I'll just write in fractions. 19 times 3 is 27 by 2 because we have written everything in fractions. T plus 3 the whole power 2 thirds plus C. This must be the answer. I hope this is correct. I hope I've not done any mistake. There is some mistakes here. No, I think so. It's all right. 2 thirds. Here, let's see the substitution, the solving. 9 times 3 would be 27 by 3. I believe what I've written is correct and this is wrong because over here we have 2 thirds. Yeah, you have to multiply 9 times 3. Okay, thank God. Whatever I did, this is absolutely correct. You can see here the same answer, but there is one error over here. What we had got, it is 27 by 2. That is the correct answer. It's not 18 here. 18 is for the previous one. This is 27 by 2. So this is how we solve this problem. A bit lengthy because, we had squared, we had to split it out and all that. There are no exact steps over here, but if you follow this, what I've done, this is the accurate steps. This problem is not similar to the previous problem, but it's a different way to solve altogether. Here, there is no method we can solve this directly. You can't take u as something because there's nothing up over here. So what you can do is, you can just assume the down thing entirely to be u is equal to square root 1 plus square root x. And then we have to find dx. So what we will try to do is, we'll find what is x value first. We will simplify everything, get x and then derive it. What I mean is, we'll square both the sides. It's going to be u squared 1 plus square root x. Take 1 to the other side, and u squared minus 1 is equal to square root x. Square again both the sides. It's going to be u squared minus 1 the whole squared is equal to x. Now if I derive both the sides, what's going to happen? I can get dx by du. Let's derive both the sides with respect to u. So this will be 2 times u squared minus 1, the power 1, so I'm not going to write it. And what is the derivation of inside terms? It will be 2u minus 1 will be 0 is equal to dx divided by du. So now I'll just take this du to the other side. It's going to be 2 times u squared minus 1 This is, I'll just simplify here only. 2 times 2 is 4. 4u multiplied by u squared minus 1 will be equal to dx. This is du times du is equal to dx. Now we can work on this given question. See, 1 divided by, what is this entire thing? It's u. What is dx here? Dx is this entire thing. I'm going to write in the numerator itself. It's 1 by 4u into u squared minus 1 du. And now this u and u can be cancelled and everything is in the numerator, right? 4, I'll write it outside because it's the numerator, it's a constant. And bracket u squared minus 1 du. Can we integrate this? Of course, we can easily integrate this. 4 multiplied with, what is the integration of u squared? It will be u power 3 by 3 minus u plus c. So we can multiply 4 inside or we can leave it outside. Now we just substitute what was u. So these big things, right? You'll substitute it back. You can just write the 4 outside because you have just multiplied 4 2 times inside. You can write it like this as well. It's distributive property. Let me do it like that. 4 by 3. What was u? It's root of 1 plus square root x the whole power 3 minus, multiply 4 over here. What is u? It is root of 1 plus square root x. So that is the final answer. And don't forget the plus c. So that must be the final answer. Let's look into the answer. Yeah, it's 4/3. Now they have written by 2. Why is that? Because I've written square root. That's absolutely fine. You can write the next step divided by 3 by 2. It's up to you. Here they have written the answer as 4/3. Not writing the square root, they have written 3 by 2. I've written the square root to the power 3. It's the same thing. And even over here, it's minus 4 times 1 plus root x. But here what they have done is half plus c. So this is how we have solved this answer. This is how to solve it. And it's a bit tricky because, there's no exact way to, know, okay, this is the method for this problem. Looking at the problems, you need to think a little bit and then you can get this method because there's no way you can solve this otherwise. So whichever they give you for writing, no matter what, they can be solved in one way or the other. Most of the time, a simple problem will be asked, not complicated like this. But if you can see there's nothing to be done, then take this entire thing and try rearranging and get in terms of x and then derive both the sides with respect to u and solve it. Let's go to the next one. Okay, here another problem. It's another tricky method. Let's look at this first. See, there is square root x to the power 4. If I take u as power 2, you will have, u square minus 1, and then I can use an inverse trigonometric function identity. And if I take u power 2, see, if I assume u is x power 2, sorry, when I derive it x, there can be something that can be done over here, right? So let's derive this. It will be du by dx, that is equal to 2x. And now let's rearrange du divided by 2x will be equal to dx. But what about this x power 4? Let's square both the sides. U squared will be x power 4. So we can substitute this as u squared. Now let's write everything over here. 1 divided by, what is x? X as it is because it has to be transformed to something else now. What is this x power 4? It is u power 2 minus 1. Dx will be du by d2x. Look here, it doesn't cancel off because they're in the denominators. So first let me take half outside, integral 1 by x, and x will be x power 2 square root u squared minus 1 du. Now we cannot solve this because you have x and u. You need to get everything in terms of u, but we know u value is x squared, right? So I can write this as half integral 1 by u square root u squared minus 1 du. Now you might remember the identity. This is secant inverse. 1 by u square root u squared minus 1 is secant inverse, right? So half of secant inverse of u plus c. This is the answer. But u was assumed to be x squared, so I have to just write 1 by 2 secant inverse of x squared plus c. This is the final answer. So here what happens is when we simplify it, you get x squared, but make sure you substitute back u, and then see, looking at this identity, you will understand this is a secant square identity, but you should have u over here. It's not any other term. It's not u square as well. It should be 1 by u into square root u square minus 1 is secant inverse. So derivative of secant inverse x would be 1 by x square root x square minus 1. So it's just that we have over here u, so we write u and then we substitute whatever was the assumed u value. So it should be half secant inverse x squared plus c. That's how we solve this. Now we move on to the last type of problem where the limits are given. It's from 0 to 2 and different types of limits. But the problems are similar. We have already done these before. So what do we do here? You just have to take whatever is inside the square root as u. U substitution, u is equal to x squared plus 1. Now derive it, du will be 2x plus 0. We don't need to write it. It's du by dx here. We need to get what is dx. So it'll be du by 2x, that is equal to dx. We got it. How about we substitute over here? This is x, and then what do we have? Square root u du by 2x, where x and x cancels off. But what about the limits? Are the limits the same? The limits were for x, but now you have re-changed it. You substituted a lot of things and changed it up, right? So even the limits will change. Let's see how the limits will change. Say this u function, because now it's not in terms of x, it is in terms of u. So what is u of this limit 0? Basically, it was 0 if it was x, right? So we just put over here, wherever that u substitution, we have assumed the u value. Over there, put the x value as 0 because the initial values of 0 was supposed to be for x. So it will be 0 squared plus 1, that is equal to 1. What about u of 2? That is the upper limit. That will be 2 squared plus 1, that is 5. So now the lower limit is 1 and 5. The limits also change. This is the important part in this type of problems. Now we know it is 1 to 5. And what about this? 1 divided by 2 can be removed out, and we have square root u du. We can solve this up. It is u to the power half. I'll directly solve this up now. It's going to be half, and this is solved as u to the power half plus 1 will be 3 by 2. And over here, what's going to happen? Divided by 3 by 2, I'll just write it out. It'll be 2 divided by 3 plus c. These coefficients can be solved easily, but I forgot to write the limit here. Now the limit is very important. The limit for u, only the variable, is from 1 to 5. That is plus c over here outside. Now you can avoid, now over here, instead of this plus c, I can avoid it. You do not need to write plus c. Why is that? Because the c and c cancels. I'll show you in a minute. Now let me simplify and write what is known. It's 1/3. I'm just writing it over here. U to the power 3 by 2. The limit 1 to 5. How do you apply the limit? It's upper limit minus the lower limit. So 1/3 is outside. Here, instead of u, you put this value, whatever is there. It is 5 to the power 3 by 2. It's not 5, sorry. It's 3 by 2. Yeah. 5 to the power 3 by 2 minus the lower limit, 1 to the power 3 by 2. Is that clear? Now, if we had the plus c, here it would be plus c minus of again plus c. It will be minus c, right? The c value cancels. So you don't need to write it. Here plus c, and when you multiply the minus and it will be minus c, it cancels off. So for definite integrals, you do not need to put the constant of integration. That c value is not there. Now what next? Let's just put this in the calculator. It'll be 1/3 multiplied by 5 raised to the power 3 divided by 2. It's not calc, I'm sorry. It's 3. Power is 3 by 2. It's 1.5 minus 1 raised to 3 by 2 is 1 itself. It's 3.39. So the final answer would be 3.3934. This will be the limits after you apply the limits. So let's look into the answer. Now they are written in fraction forms. You can just leave it like that. I'll just explain what they have done over here, but this is absolutely correct. You need to do the step 1, use substitution. Step 2 is finding the new limits. So here the step 1 is this 1. Step 2 would be the new limits. Step 3 would be substitution. Step 4 would be the applying the limits and solving up. So this is all important. Now let me just explain why the solution set answer looks different. If you put this in the calculator, the answer will be same. I'll show you here. We have got 3.3934, isn't it? So let me just solve this up. It'll be 5 divided by 3 times root 5 minus 1/3. 1 divided by 3. It'll be the same thing. It's 3.3934. Why is it? Let me just show you. We had, how much did we have? It's 5, 3 by 2, isn't it? So 5 to the power 3, and it's a square root. So 5 to the power 3 is 125. That's why we have 125. And 1 raised to anything is 1. And we had 1/3 outside. This is why. And then what happened over here is 125, root of 125 can be written as 25 times 5. And 5 is a square, perfect square. You can write this as 5 root 5. If you put square root 125, I'm not sure in your calculators generally you get this form. You might even get you might get decimal or this form as well, radical form, you will get it. So this is the answer. Now you're multiplying 1/3 inside. So 1/3 over here will be 5/3 root 5 minus 1 times, it'll be 1/3. So that's why we got this answer. It's absolutely same. Whatever I'd written, that's more than enough. You can write in decimal point. It should be the correct answer. Or you can leave it over here at this step. What about the next problem? Let me solve this. What is u? Whatever is inside sine, we just take it as u. So u is pi x squared. Because we can easily solve sine u, isn't it? Now let's derive this. Pi is a constant, so du by dx would be equal to 2x, and pi is a constant. Now let's write dx. Du would be 2 pi x. I've just written pi over here, 2x, 2 first, 2 pi x, that is equal to dx. This is not done. We need to do the step 2 for the limits. U of 1, because over here the option, first limit is, lower limit is 1, will be pi times 1 squared, that is pi itself. Pi times 1 squared is 1. 1 squared is 1 times pi is pi. What about the second limit? Here we'll have pi and 3 the whole square. So it'll be 3 squared is 9 pi. So these are the new limits. I hope you remember you can directly solve these definite integrals and calculate. You can type this out as it is, you'll get the answer. But since it's the writing exam, I'm solving it by writing. Now here the new limits formed are pi, 9 pi, and we have x sine u dx will be du by 2 pi x. X and x is cancelled. So what is remaining here? I'll remove the 1 by 2 pi outside, and you're remaining with pi, 9 pi sine u du. We can easily solve this. The answer would be, if you solve it up, 1 by 2 pi. And here, when you integrate sine, it is minus cosine. So I'm just going to write minus outside. Cosine u. That's it. Plus c. I'm not going to write y because it's the definite integral. Now don't forget the limits. I just almost forgot. Pi to 9 pi. Now I'll just continue it up over here. Over here I'm just continuing it. So we have minus 1 by 2 pi outside. What happens here? Make sure you apply the limit to cos u. So you're not going to substitute back this values or anything. No, we're just going to apply the new limits. So what we do over here is cosine 9 pi minus cosine pi. So this is what we need to solve. We can just put this in the calculator and we can find the answer. So let's see, it's minus 1. I'm not going to leave it in radical forms or anything. I'm just going to do it directly in the calculator. Whatever the answer is, you can just write, because all the steps are done. The step 1, step 2, and over here step 3. And now we apply the limit. That's the last step. Cosine 9 pi. So it's pi shift and the symbol here. Minus cosine pi only. Close the bracket. And make sure you convert to the radian. See, it's in degree mode. Shift mode 4 gives us radian. So that's the answer, because these two cancel off. Okay, they're coterminal angles. It's the same values basically. Cosine 9 pi and cosine pi. So the answer will be 0. So that's the final answer. Here you can see. That's it. We have to don't do what they have shown over here because they have not done the steps properly. It is very important for you to do the steps. The step 1, the step 2, step 3, and the final step. Let's move to the next type of problems. Again, it's the same limit problems. And over here, it looks complicated, but all you need to do is whatever is down, just put it as u. U is equal to t squared plus 1. du by dt would be 2t. And du by 2t is equal to, sorry, du by, 2t is equal to dt. But it's not over. We have to find the new limits. So u of negative 1, the lower limit first, would be minus 1 the whole squared plus 1. And u of positive 1 is also the same thing, 1 squared plus 1, because the squared, right, negative will become positive itself. It's 2 and 2. Now here, whenever you take the definite integral at the same limit, it's 0, because whatever the value minus the same value will be 0. But anyways, we'll do the steps. So what we do is this particular given function, you need to write it in order. I'm just not writing in order because I'm just solving all these problems here directly. What happens is integral, the new limits is 2 to 2. The upper value is t for now, but this down one is u squared and dt is du by 2t. So this t and t cancels off. So I'll just write it over here. What is remaining with you is integral 2 to 2. And you have only 1 by u squared du. When you solve this, this 2 comes up. It will be minus 3, minus 2. And when you add 1, it will be positive, negative 1, basically. So integral 2 to 2, it's going to be minus 2 plus 1. That's minus 1 divided by minus 1. I'll just write the sign outside the integral so I remember it. And I'm not going to write plus c because it's definite integrals. And what happens now? Here, all you need to do is apply the limit. So, I'm sorry, you don't write integral once you apply the integral. So, it's already done. The integration is done. So, you just write like this, the limits. Now, minus, let it be outside. 2 to the power minus 1 minus, again, 2 to the power minus 1. Doesn't matter what integration you got. Whatever is this values. When you apply the same numbers and you subtract with the same numbers, it's 0. 2 minus 1, it's 1 by 2. Half minus half is 0. Doesn't matter what sign, it's 0. The answer will be 0 here. So these are the steps. Make sure you don't write directly 0. I mean, if you had written the statement, the lower limit LL, okay, just abbreviation, and upper limit, that is UL, are same, hence integral will be 0. Integral, definite integral is equal to 0. You can write this. If it was me correcting over here, I would have given you full marks because you understood over here. There's no point in solving. Even if you solve, it will be 0. But it's, to be on the safer side, it's better to write the steps because it's anyways you know how to solve it. So just write the steps and it'll be 0 here. What about the next problem? Here, let us take t to the power 3 as u, because when I derive it, I'm going to get t to the power 2 and I can simplify this. I can cancel it off. So here u is equal to t to the power 3. du by dt is equal to 3t squared. And du by 3t is equal to dt. It's not over. What is the lower limit? U of 0 will be 0 to the power 3. That is equal to 0. What about the upper limit? It's 2. So it'll be 2 to the power 3. It's 8. That's the answers. Now the value over here changes to 0 to 8. T squared e to the power u du by it's 3t power 2. So this cancels off. What happens? 0 to 8. Over here it's 1/3. And then what do we have is EU du. Let's apply the integral. When you apply the integral, it's just the same thing because EU integration is EU itself. But we are applied from 0 to 8. No need of writing plus c. Here 1/3 remains whatever is the limit. We are applying the upper limit first. It's not 8. It is e to the power 8 minus e to the power 0. anything to the power 0 is 1. So you can just write 1/3 into e power 8 minus 1 is the answer. You can put that in the calculator, or you can leave it over here. It's fine, because you apply the limit. Even if you leave after just applying the limit, you must get the full marks. So now what I will do is I'll just type it out. 1/3 multiplied with e is, I can just press shift and ln. You get e to the power 8 minus 1, close the bracket. Reason is e to the power 0 is 1. It's 993.31, but let's see how they have solved it. This they have written directly 0 because of the same limits. Now here we have got 1/3 e to the power 8 minus 1. They have just left it over there. You can also do the same. Or you can even write the value in the next step. Now these problems, okay, this is pretty easy. I'll first solve the 36th one. Whatever is in the denominator, make it equal to u, 1 plus e to the power x. So why do we do that? Because when we derive e to the power x, is the same thing. So du by dx would be only e to the power x. It's 0 plus e to the power x. So du by e to the power x will be dx. Now don't forget the limits. It changes. What happens over here? U of 0, use the first initial assumption of u. That is 1 plus e to the power 0. And what if it's u to the power 2? It's 1 plus e to the power 2. Now for here, rather than substituting and solving, I'll just leave it like this only. For this one, I'm going to leave it like this. But what about the first one? It's 1 plus 1. E to the power 0 is 1. So it's going to be 2. So it's e to the power 0, that's 1. 1 plus 1 is 2. So it's 2 to 1 plus e squared. So the new limits formed are 2, 1 plus e squared. And what about this? Here, let's do the substitutions. E to the power x divided by u will be du by e to the power x. E to the power x cancels off. So you're just remaining with 2 to 1 plus e squared, 1 by u du. What is 1 by u value? It is ln u. Now you need to apply the limits. 1 plus e to the power squared is the upper limit, and down we have just 2. And let's apply over here. ln u is 1 plus e squared minus ln 2. So you can leave it over there because that must be the answer. Let's just look at the second answer first. Okay, they have used the properties. Now that's correct what we have done. Absolutely correct. But what is the property of natural logarithm? When you have minus, these terms can be written as division, right? ln 1 plus e squared divided by 2. That is the final answer. This is the simplified form because we are using ln a minus ln b is equal to ln a divided by b. I'll write the rule. If it's ln a minus ln b, sorry, not that. This is equal to ln a divided by b. This is the rule. So that is what we have applied over here. Therefore, the answer you can see is over here. That was an easy one, but what about the first one? It's a little bit different, right? Because we don't have e to the power x over here. So what we will do is, here, if you take e to the power 2x as u, it's not going to work out. Why? Because if you take like this, it's going to be 2e to the power 2x itself when we derive it. And we can't cancel each other out. So what can we do? Okay, what if I take e to the power x as u will be e to the power x. Let me derive it. It'll be du divided by dx is e to the power x. Now du by e to the power x is equal to dx. Okay, I can cancel this ex, but u is only that. So I can't do u substitution and then I'll just get extra variable. But what if I square the first given term? U is equal to e to the power x, right? What if I square this up? U squared will be e to the power 2x. Now, what if I write over here as u squared? That will work, absolutely. And what about the limits? So limits would be u of 0 and u of 2. First one will be, now here, don't write in the second equation, not u squared. We have to look at the u, whatever we substituted over there. It'll be e to the power 0, that's 1. And over here, it'll be e to the power 2, that's e to the power 2 itself. That's it. So this is what we do. Now we got the new limits. So e equals to, from 1 to e squared. What is this e to the power x? Let's write it just like that. Don't put it as u, because our goal is to cancel this off, and we have this as u power 2, whereas this will be du by e to the power x. But if you put this as u, then again put u and then it cancels off. You can do it like that, but it's better to leave it, and now it cancels off. So what is remaining here? 1, from here I've written down over here, e to the power 2, that's e squared. And we have 1 by 1 plus u squared du. This is tan inverse, isn't it? So when I apply the integration, it will be tan inverse u, because 1 by 1 plus x squared is tan inverse x. The limits are e squared and one lower limit. So we apply the upper limit first. It will be tan inverse of e squared minus tan inverse of 1. That must be the answer. So if you look carefully, okay, tan inverse of 1, you can put that in the calculator, but that's the answer. Let me show you how you get the tan inverse of 1 as pi by 4. In your calculator, you can just press shift and tan, and then 1, it'll be 1 by 4 pi. That is 45 degrees. So that's tan inverse of 1 is 45 degrees. You should have, I mean, you might have known. You can directly write it or just use your calculators. And we do not need to simplify this, because tan inverse of e to the power 2 is some weird value. Rather than that, we'll just leave it like this. Okay, like this over here. You can just finish this answer off by writing tan inverse e squared minus pi by 4. That's the final answer over here. That's it. So the first problem, we have to take u as e to the power x. But then when we are using the u substitution, we use u squared for the down term, and the above term gets cancelled off. So that is one thing you must remember. See, when it comes with exponential integrals, so remember these tricks. Whereas the second problem was pretty easier than the first one. It's all same, just the differences. Over here down, denominator, it was 1 plus ex in the second one, whereas the first problem it's e2x. What about these? Now, cotangent. Do we have any rule for cotangent? No. But we know cotangent is cosine by sine. So here, first the given question transforms to pi by 2, pi by 4. Cotangent is cosine x by sine x dx. Now whatever is in the denominator, you consider to be u. U is sine x. And then what we do is derive this. Du by dx will be equal to it's cosine, positive cosine. Be careful, sometimes I get confused because we have derivatives, we have integrals, so you need to be thorough, practice more problems, then it will naturally come. You will not be confused with these identities. Now this is the derived one. It will be du by cosine x, that is equal to sine, dx. But it's not over, we need to find the new limits. So u of pi by 4 will be equal to sine pi by 4. And u of pi by 2 will be equal to sine pi by 2. We will just substitute these values in the calculator. Here we will type sine pi by 4. It is pi divided by 4. Sorry, it is decimal here. Now, if it's not in radian mode, you have to press shift, mode, and 4. And then if you press equal to, you'll get this answer. Okay, what is this exactly? Root 2 by 2. The reason is when we solve this, it'll be natural logarithm when we have these problems. So it's better to write the actual form. Instead of root 2 by 2, this is equal to root 2 by root 2 root 2. What do I mean by this? 2 can be written as 2 times root 2. When you multiply, the square root cancels off. So it's the same thing. So I can cancel these both, and 1 by square root 2 is same as root 2 by 2. I will prove it by just pressing SD. It's 0.707, right? And 1 by root 2 is also the same thing. See, it's the same thing. So we can just write 1 by root 2. And what next? We have sine of pi by 2, which is 1. Pi by 2, it's shift pi, and divided by 2, it is 1. So we will write it out over here. I'm going to write 1 by root 2, and this is 1. Let me just clear this off. And even if you write root 2 by 2, it's okay. That's no problem, you know. What happens here? Here now, the limits are changed. The lower limit, pi by 4, we have 1 by root 2. And what about this? It's 1 over here, isn't it? The upper limit. And cosine remains for now. Sine is u. This dx will be du by cosine x. Cancels off. Your 1 by x du remaining. I'll directly solve using the integral. It'll be natural logarithm u. The limit is from 1 to 1 by root 2. Let's apply the upper limit. What happens? It'll be ln 1 minus ln 1 by root 2. Now, what is ln 1? If you remember, it's 0, or we can just use the calculator and solve it up. Here, natural logarithm ln 1, close the bracket, and the answer is 0. So the first part will be 0. It's just minus ln 1 by root 2. So that is the answer. You can leave it like that. So you can see the answer is, okay, they have simplified it further. I'll tell you how the simplification is done. Do you recall the property that is ln A minus ln B? What happens here? This is equal to ln A by B. Similarly, if it's A by B, that is one term divided by the other term, you can use this upper formula. So let me write this minus outside. And here we have ln 1 minus ln square root 2. ln 1 is 0, so it's minus of minus ln square root 2, which will be equal to ln square root 2. So this is the answer. If you're getting too much confused after this step, just put this entirely in the calculator. You will get the answer decimal. You can just write it over there. But this is the actual way to simplify, and this is the simplified version. If you're aiming for a perfect score, like perfectly understand this, then I would suggest you understand how it's done, and then you only can solve it until over here. So ln square root 2 is the final answer. That's over here as well. What about this problem here? Now this is pretty easy because you can see ln x is more complicated term. So if we take this as u, we can easily eliminate x because derivation of ln x is 1 by x. Let's assume u to be natural logarithm of x, and du by dx will be equal to 1 by x. So what is du? That is dx, but the x multiplies with du. It's not over. U of 1 is equal to ln of 1, that is 0. And what about u of e? So this is ln e. What is natural logarithm of e? It is 1. Why? Because they're inverse of each other. They cancel off. It's 1. So it's 0 to 1, the limits. So here the limits turn out to be 0 and 1. The lower limit, when we apply 1, it's 0. When we apply e, it is 1. Now let's write natural logarithm, that's u here. U divided by what is x? Let's write it for now. But the dx is converted to x times du, right? So x is cancelled off. So you have 0 to 1 u du. What's the answer? It's u squared by 2. Apply the limit from 1 and 0. So I'll take this half outside, and you're remaining with u squared of 1 and 0. This is for the u squared. Half of 1 squared minus 0 squared. The answer is 1 only over here, so it's half. So that's the answer. These are the exact steps. You can skip many steps, you know. Just in the mind, you can from here directly jump down to here as well. Half is written outside, 1 squared minus 0 squared. So you don't need to do all the steps, but you know, if you want, you can follow that. So the answer is half for the next one. And the first one we did, it was natural logarithm root 2. We have reached the last two problems. I'm not sure anyone has stuck through all the video. It's such a long video. But if you have really watched the entire thing, then well and good. I'm sure you might have understood the integration by parts thoroughly. So let's complete the last two problems now. Here, what we need to do is, you can see, we do not need to substitute anything. We can just simplify this directly. Don't get confused because we are doing all use substitution. Don't jump to the substitution part. Here, firstly, 1, 4. What happens? It's x divided by root x minus 1 by root x. This all dx. So here it's x power half. You can write it as x, this is 1 minus half, and over here this x half, right, just bring it up, it'll be x minus half. 1 by root x is 1 by x to the power half, that's positive. When you bring it to the numerator, it becomes negative. This all thing dx. So we have simplified it to x power positive half minus x power negative half dx. Let's just apply the integral directly because we know the integration for both of these, and we'll get the answers. Here integration will be 3 by 2 and outside will be 2 by 3. You have done this before, and the limit over here will be from 4 to 1 minus, here it's going to be positive half, and the 2 divided by 1, I'll just write 2 over here, and the limit over here is 4 and 1 itself. So what's going to happen here? It's 2/3 of 4 3 by 2 minus 1. 1 3 it's upper limit minus lower limit. Doesn't matter what you have to the power of 1, it's 1 itself. So I leave it over there. Minus 2 times, what is it over here? It's 4 to the power half minus 1. So this is the final answer. You can simplify it. I'm not sure they might have left it like this. Okay, they have simplified it to 8 by 3. Let me do that as well. Here what happens is, see, instead of simplifying like that, I'll just put this entirely in the calculator. It'll just save you time. 2 by 3, open the brackets, 4 to the power 3 by 2 or 1.5 minus 1, close the bracket, minus again 2 times, open the bracket. You can write multiply over here, or even if you don't multiply, it's automatically multiplied. It's not squared, it is 1 divided by 2, and it's again minus 1. Close the bracket. The answer is 8 by 3. Directly you get it in the calculator because 8 by 3 is a simple fraction. It'll be shown. So that's the answer. As long as you have done these steps, proper steps, you must get proper marks, full marks for this. What about, over here, you can remove these terms common out and then solve. There are various methods to do it, so that's why, you can follow whichever is convenient for you. What about this one? It's again another simple problem. Let's do the last one here. Whatever's inside the square root, I'll substitute it as u, that is equal to x squared plus 1. And du by dx would be equal to 2x. And du by 2x would be equal to dx. Next, we have to take the limits of u of 0, that will be equal to 0 squared plus 1, that is 1. And u of 1 will be 1 squared plus 1, that is 2. Now this entire question transforms to the limit. Lower limit is 1, upper limit is 2. And we have x divided by square root u du by 2x. This x and x cancels off. And you're remaining with 1 to 2. Half, I'm going to write it outside. This divided by 2, half is written outside. U is power half. I'll take it up, it's going to be negative power half. Why? Because square root is power half, right? I took it up, it becomes minus half du. And then let's apply the limits. It'll be half. Let's apply integration, sorry, not the limits. It'll be u to the power half positive, and divided by half, the 2 comes out over here. It's all multiplied, and the limit is from 1 to 2. 2 and 2 cancels off, so you're just remaining with u to the power half with the limit of 1 to 2. Now let me do it. 2 half minus 1. It is basically square root 2 minus 1. This is the final answer. So here we go. Yes, that's the final answer. And that is the end of all the writing part questions. I hope you have found these videos helpful and beneficial. I wish you all the best for your exams. Please do prepare well in advance for your exams. Don't leave it at the last minute. And if you have any doubts, please try rewatching the video or ask your questions in the comments, and I'll try to get back to you very soon. And thank you very much for your support for my channel. I'm really humbled by all the appreciation and thanks I receive on the channel. Thank you so much. I really appreciate it. If you could do me a huge favor, then please do share this channel with anyone who do not know about this and who could benefit from it. And if you can, please do hit the subscribe button and like my videos. It would mean a lot. Thank you very much, and bye-bye for now.